Welcome to a new test and teardown video. This time it's a sine square oscillator called LF1 from the company Farnell in England. And it covers 10 Hz to 1 MHz. Got a little bit of stickers here in the front. I always complain real loud and nasty about all those stickers in the front. Why would anybody love to put stickers and numbers and whatever on the front? Can you please tell all your friends to put stickers somewhere else, any other place actually? This one is a little bit older than I first imagined. Look at this sticker here. So it's from a Danish company called Storno, and they made land mobile radio systems. So the department is called this, and CQP, that is the name of this radio system. Look at that date, 78. They even got the price, and the vendor is ITT. Maybe this is where they bought it or something like that, because I thought it's called Farnell, right? So is it called ITT somewhere here on the back? Farnell Instruments Ltd. Well. It looks quite modern. Would you really think? 1978? Yeah, I better open and do a little bit of inspect and remove all those nasty stickers. This one definitely I need to keep. That is fantastic with all the information. But here at the front, I really don't like all those stickers. So let's do a little bit of a cleanup and then open. Ooh, I guess some sticky. What is happening here? Is that the wires or something? So look at that. After a little bit of cleanup. Would you think this one is from 1978? How about that? I only cleaned half of the top here to the right. And please only use water on stuff like this. This type of silk screening and this paint cannot tolerate alcohol. Normally alcohol is very effective against stickers and stuff like that. And the paint, the background here handles alcohol fine, but not the text. So that is very, very important when you clean stickers and all that. So that was fairly easy to open this one and just pull it out. What really bothered me, this one is so loose and annoying. It makes all sorts of noises, and also when it's assembled, we still need to hear all this. I don't understand why this one is so loose while the back one is not. Maybe I want to give it a little drop of contact glue, and that should stop all that. And then I think we just, maybe just pull a little bit like that. Whoa, that is nice. Look at that beautiful, huge variable capacitor here. That is beautiful. Ooh, look at that. The two blue wires twisted together like that, and even added a tiny little drop of glue. That is, of course, another little trimmer capacitor. And is that just a shield or a protect? This is for mains. One of them will be, this one is mains. So I think the idea is just to protect everything here so you don't stick your fingers in here. Okay, here, this is where we got mains. These are not sockets, right? So that will be a, that will be the power supply. And VT100 What exactly is that doing? That is interesting. Oh, that's just a transistor. Okay, yeah. All the transistors, they're just called VT. Really? Transistors and caps. No leaks so far, and that will be the different frequency bands. All that is there. This is what this board is doing. We got a little IC down there doing some. Oh, that is the oscillator, and look at that little glass thingy. Yeah, we're gonna go and have a look. Transformers, tiny. You can of course switch this 240, 115, and then 0. Okay, easy. Did I say about this gearbox here? There is a super good feeling to that gearbox, and it's made with ball bearings inside here, and they go around in there, and it's just a brilliant mechanical construction with no slip or backslash. So yeah, I really like that. And again, here we got anti-backslash gearbox. So all that is good. And that one is a little, you could call this a light bulb or an NTC resistor, or yes, whatever it is like that. And they are used to handle and compensate temperature and level for the oscillator. So that will be the oscillator board doing the different, and then, so you change sine, square, that is done on this board, and then you just select, so that means we got probably just some transistors here doing that. There is not a lot of electronics in this one, really. I was expecting some high power output driver transistors and something like that, but all we see is just those little tiny transistors. That's it. There isn't any big sweaty transistors. Yeah, beautiful circuit board layout, and isolation so you don't get hurt, and that will be the power on indication. Yeah, I kind of like everything here. There's no safety issues, there's nothing dangerous. Power in out is shielded and done all good ways. So yeah, let's just power this up and play. So here we go with this sine wave or square wave generator. We got quite a lot of problems with this. Maybe you can see the ripple. Let me turn down the time base here so it's easier to see what exactly is going on. So we got quite a lot of ripple, and this is the highest output. So if I crank down the output and then gain, I think it's actually the same. So this reveals it's not a ground looping problem, but it is actually on the output, and then it's also divided down and all that, right? So I need to investigate on the power supply. Frequency adjustment is very, very accurate. So all that is perfectly fine, but look at that. Here is your ripple and unstable behaviors. That is not looking good. And oh, here we go. We got output, but it's really maybe, oh yeah, look at that. So it's the switches. They need to be, this one is not working at all. Probably this is the one. Oh, we got it. So that is 5 kilo output. And again, frequency is super, super accurate. Yeah, so I will go and clean the switches, and then I will look at the capacitors and the ripple and all that kind of stuff. I decided to change all the capacitors. Now I was in the middle of it anyway, so why not just, yeah, go ahead. So the 3 here in the supply, they were normally 220, so I just put in 470. So we double all these. That's important for the power supply. And the last 2, here we go. They are a 470 and only 6.3 volts. But I put in the same higher voltage types because you can always go up in voltage anyway. So, and there you have it, a perfect, nice and stable sine wave. And all the different levels they work, of course, and then all the different frequencies also work. Look at that. See, and there's not any more of this annoying. So I think I will just end this video right now and just say thank you very much for watching, and remember to change them capacitors. See ya. Bye bye.